Can you hear me now? And you didn't hear anything before. Okay, so I was just talking about what we discussed yesterday, different pattern and how exactly you can make use, how exactly those patterns are in usage. Today we are going to start off with module pattern. So to start off with module pattern actually uses different patterns in within itself to configure itself. So for example, let's say if I have to define something in module pattern, let's start with this expression. Can you tell me what this expression is called? If I'm writing an expression something like this, what is this expression called? Do you know which pattern is this? Yes, this pattern is called your IFI. The short name for that immediately invoked function expression is called your IFI. So now what we did, we have just created an anonymous function. Anonymous function as in which is getting invoked by itself. Let's say now if I have to declare a namespace for it, a namespace as in so that I can access it globally, I can access it by some other modes as well. For doing that, what I am going to do, I will just declare, I will use it as a module. I am going to say, let's say where module is equals to this expression. So what I'm saying that rather than, let's say this function will invoke itself, but I need it to be available throughout my global space, throughout my JavaScript or throughout my application. So what I'm doing, I'm collecting it into a module. So it's typically when I have created a namespace for an IFI expression, we are approaching towards writing our module pattern. So first of all, let's say we have done this. Now what else you are going to do in your module pattern? What exactly your module pattern provides us? Module pattern is one of the most used pattern when it comes to following your encapsulation concept. What is an encapsulation in your OOPS or in your object oriented programming? Encapsulation is one of the most is one of the OOPS concepts that says it talks about wrapping up of or collectively providing the properties and behavior within itself. Let's say if you have a object, that object can have multiple properties, that object can have multiple behavior associated to it. What encapsulation says that whenever you are putting those things together, whenever you are encapsulating the behavior and properties of an object together, that OOPS concept is called your encapsulation. Encapsulation is generally achieved by grouping up of your properties and the behavior that will operate on those properties directly within at one point. So what your module pattern is going to do, your module pattern will be allowing you to include your both your public and private methods and variables within a single object, and henceforth shielding them from outer penetration. What do I mean by that? Let's say if I'm creating an object, let's say if I'm creating an object for a car, whenever I'm saying car, I have to provide some functions for it. I have to provide some methods that can operate on that car. Let's say can drive or have airbags or something like that, and then I have defined some properties with it, which is like the color or anything as such. But what I'm saying that if I'm just going to write, if I'm someone who is very new to JavaScript, if I have to write these types of functionality, I would probably just keep on creating the functions and functions for all the functionalities that will belong to my car object. I can create function 1, function 2, and so on. But what module pattern says that why are you letting everyone access your methods, why are you letting everyone access your functions when they belong to only one object? Tomorrow, let's say you have created, you meant those functions to be created for a car, but let's say tomorrow a two-wheeler or a plane object or anything at all can access those because you are providing them into a global scope. So what your module pattern says that things belonging to a single object can be put inside in the format of a module, and hence you are going to have a option that which part of your methods are supposed to be accessed by things outside your module. You will have a control over what you want to expose, what you do not want to expose by using your module pattern, and the things belonging to one object are going to be put inside one type of module. Now what your module pattern says, it provides you a different form of privacy as in having said that said that privatization, JavaScript does not actually talk about making anything private, but yes, you can achieve some sort of privacy in terms of what you want to expose outside the scope of your modules or outside the scope of your methods that you have created. So what your using your module pattern, we are going to provide a very clean solution which will tell us that only this part of my application or my functions needs to be exposed outside. Rest everything we are going to shield by the usage of private functions or by the usage of private variables and so on. So that's what your module pattern is going to do. Module pattern will be including your literals, it will be including your IFI pattern, and it is also going to make use of your closures in terms of what we are going to define or how we are going to access anything using our module pattern. So to begin with, let's say if over here, this is what I have defined. Now let's say I'm creating a variable called where counter equals to 0. Can you tell me why did I provide underscore before it? Before the counter variable? Is there any specific meaning behind it? Do you know? Okay. Can you tell me what is the scope of this variable? Yes, this is a local function. So there is a convention that JavaScript follows for any of the private variables, for any variable which you are creating as private as in which is local to one function. There is a naming convention that JavaScript follows, that is to put an underscore before the name of the variable that you have created. That's just a naming convention that people in JavaScript generally follows to create variables which are private to a function that you have created. So now, let's say if I want this variable to be accessible outside, let's say I'm creating a function first of all. Okay, so this is a function that I have created that is going to return this counter, increment of this counter. Can you tell me when I do something like this, what is this called? No. Have you guys discussed about closures? Okay, There is a concept in JavaScript that says, let's say, whenever you are declaring any private variable, whenever your function is having a private variable, outside people outside the scope of that variable will not have an access to that private variable. So in order to provide an access to those variables, what you can create functions that will allow you to access those variables, just like what we did. We created a getter function, if you remember, tomorrow. So what a closure is going to do, closure is just a variable, closure is just a function that will allow you to have, or to have a reference to the private variables within your methods, within your functions that you have created. So in simple term, a JavaScript closure is nothing but a function that has a pointer reference to the variable, which is a private variable. So another term for your closures is called, they are called your free variable. So let's say whenever your class, whenever, let's say for example, let me give you an example for closure. Let's say if I'm creating if I have something like this, let's say I have created this person object which is having this function reference, and inside that I have created a variable which is private to it. If I'll try to access this variable outside, if I, let's say, if tomorrow if I say person.name, do I have access to that variable? Can I do this? Can I do this? Why not? What will be the output for it? If I say this person.name, what will be the output? Exactly, it will give me undefined. So what I can do, I still have to have an access for that. I can create a function. Let's say I'm creating this method inside this dot get name, and let's say function, and over here I will be returning the name that I have just provided. So whatever variable I have created, let's say I have created this variable, I need it to be available after setting this value. So what I can say, I will simply return this underscore name from here by the usage of this function which I have just created. So this expression that I have just provided, this expression which is allowing me to have an access to the variables, this thing which is now allowing me, now if I have to say person dot get name, will I have access to the variable now? What do you say? Yeah. So let's say, for example, now if I have to access that function with whatever I have created, if I'm saying person dot get name, and I will just do, or I will just provide anything inside. Let's say if I'm doing this, any name that I am passing. So using this get name function, I will have the access to the variable that I have just created. So this method which I have just declared, which is having a reference to the private variables of my object, these types of methods are called my closures. They allow us to have an access to the privately owned variables of the functions that we have created, and this is how you can retrieve, or this is how you can access anything privately, anything which is owned privately from the methods, from any object that you have created. And this is exactly what a closure is going to do for you. So the term for these types of methods that we create is called closures. They are called closures in your JavaScript. So over here, we have created this method which will allow me to have the access, to have access for the functions, to have access to the variables which are privately defined. Now let's say if I have to provide an access to, I want to shield something, I want to provide a way using which only the things which are exposed or which I want to expose should be accessible outside, but not everything. What I'm going to do, I will simply write a return statement, and I will return this function itself. So what I'm saying that this counter function is not this counter variable is not accessible outside, but this increment counter method which I have just created is accessible, which in turn is incrementing my counter. And this is how simply we are going to create, or we are going to make use of our module pattern. And this is exactly what a module pattern is. It's like shielding what you want to expose outside. If I have to do anything now, let's say any item that I want to print, what I'm going to do, I will simply call that function to print or to provide any information that I want. I will simply make use of this function to print anything that is coming in my counter. Let's say if I create another method, I say print counter now how do I call those methods which I have declared? I'll say module dot increment counter, and let's say if I want to print the value, I'll say module dot print counter. So what we are trying to do, we have shielded this counter variable from outside. We have written some methods which we are returning from the module. Every module that we have written, it should return something outside so that people can access only the parts which are available, which they want to access within this method. So what we are trying to do, we have just written a function, we have just written a method which we want to be accessible outside, that is my increment counter, and then finally we are saying print counter. So this is exactly what a module pattern is going to do. It will allow you to create, or it will allow you to shield something from outside. Anything which you are declaring as private will not be accessible, and the things which you want to be accessible outside, you are just going to return them as object reference. So these methods which we have created, they become my object reference. Let's say if you want to make more of this, let's say if I want to create this function. Now this function which I have declared, this is a private function. This is again a private function. Let's say I'm not going to return anything. I will just do a counter plus plus. I have just created a method which is a private method within this function, within this module. So what I'm trying to do, this function should just increment my counter, but I do not want it to be accessible outside. Let's say to avoid this type of situation, to access it, still access it inside my print dot counter, let me just call that increment counter function. Why is it giving me an error? Oh, sorry. Okay, so what we created a private function, we created a private method, and we are making it accessible outside by the usage of this print counter method, So whenever this print counter for outside word, the method which is being exposed, which we are returning from this module, is print counter. So outside word will have an access only to print counter. They cannot change anything into your increment counter, and increment counter is again changing a privately owned variable, which is my underscore counter. And this is exactly what your module pattern is going to be. It is going to be a combination of your private variable and your public variables, also your private methods and public methods. Whatever you want to be accessible outside, whatever you want to be accessible privately, you will just put them inside a return statement, whether it's a variable or just like using your object literal notation over here. Let's say if you want to create a public var as well, a variable which you want to be accessible outside. Let's say I create this variable. Now, as I am returning this variable, for people to access outside, what I have just defined, what I have just created, I have just created by using my object literal notation. So if you see over here, we are following object literal notation, then we are providing ify, so that we can access it access it outside as well, and we are taking a namespace by module. You can create it as any way. So this is what exactly your module pattern is going to be all about. It will allow you, it will provide you mods using which you can write, you can access anything which is your privately owned, or let's say which is your privately owned methods or variables, by providing or by writing your some return statement which will have an access, by writing the objects which is being owned, or by creating objects which you just have to return based upon how you want it to be accessed. So this is exactly what your module pattern is going to be. As simple as that, just provide a return statement to the things that you want to be accessible outside. Now let's see what are the problems here. Okay, it should be fine now. Now let's try to run it. So if you see, hi and 1 is being printed based upon how we have created those variables or how we want to access those variables, but we are accessing them through a return statement, or we are just returning an object. So this is one of the basic things that you can do. If you want, you can take a combination of your object literal pattern within this module as well. Let's say you can just create a object following your object literal notation, and then at the end, whatever calculation, after doing all your calculation, writing your methods or any operation, you can just return the object as well, and which you can access later. So this is also what you can do. So simply putting, your module pattern says that you have a way, or you can shield your information, you can have an absolute encapsulation within your application by following this module pattern, which simply says that you can scope your variables or you can scope your methods within a namespace. That namespace can be following your module pattern, and then you can shield the information that you do not want to be penetrated outside by creating something like this. Just provide those variable, write methods, write closures to access those privately owned variables, and then just return those objects which are referring to this, which are referring to the calculations, or which are referring to the objects that you want to return. Now this is what exactly your module pattern is going to be. One of the most Why module pattern is being used? Because the people who are coming from different programming languages background, who have been following, let's say if you have worked with C++ or Java previously, it gets very easy for those people to understand module pattern, because it's all about encapsulation, it's all about wrapping up or collecting your data at one place. So that is why it's very easy for people to understand module pattern and to make use of it. And then another thing why this another advantage of your module pattern is that it allows you to have an access to your private variables without you to touch anything, or without you to operate on that private data. Let's say you do not have to access those private variables, you do not have to access those private variable directly. All you are doing is you are just shielding those private variables or private methods by the usage of your public variables. So these are few advantages of your module pattern, and this is exactly how you are going to use if you are going for your module pattern. If you see, this pattern is just a combination of IFI plus object literal notation plus closures and so on. Okay, so this is what a module pattern is. Is this clear? All right. Next pattern that we have, which arises from your module pattern itself, that's called your revealing module pattern. uh, Revealing module pattern was created to overcome the problems of your module pattern. Can you think of anything that can you think of any problems or any disadvantages of using a module pattern? What do you think? If I have given you this type of scenario, what do you think can be a disadvantage of using this type of pattern? What comes to your mind? Anything that you think, okay fine, if I'm doing something like this, it can cause a problem for me later on. Okay, one of the biggest disadvantage of your module pattern is that we have created private methods, we have created private variables, private and public members, we have separated them in the sense that we are creating them or we are writing them differently. Public things are different, private things are different within one module that we have created. So tomorrow, let's say if I have to change the visibility, tomorrow I do not want any of the private variables to be accessible, to be to be as private. I want to change that visibility, I want to change the accessibility of those variable. For doing that, I have to make changes within my module itself. Either I make these variables public over here when I'm returning it, or put them in object literal notation, or howsoever I want it. So whenever there is a change that is required, I have to make changes within the in terms of visibility, I have to make changes within my pattern itself. Then secondly, let's say for anything that we are accessing privately, for all the private members in my methods that we have created, tomorrow let's say if I make any changes in my object, if I just change my object, I have passed, right now I'm not passing anything. If I want to pass some parameters, those parameters if I'm passing, obviously to have that accessibility, to make use of those private to make my private members to use those changes, I again have to make changes in the entire module that I have created. So these were the few disadvantages of your module pattern. To overcome this, there to overcome these things, there was a pattern which evolved, which is called your revealing module pattern. So what happened, that every time whenever you have to access your main object, we need to call our public methods, which can in turn, or public variables. So these are the few things that due to which revealing module pattern came into picture, which said that simply define all of your functions and variable in the private scope and return an anonymous object which will be pointing to the private functionality. So rather than just saying that this is public, this is private, do not distinguish, just put at one place everything as private, every variable, every all of our functions that you want in a private scope, all the members put in a private scope and just return an anonymous object that should have a pointer to the private functionality that we want to be revealed as public. So what your revealing pattern says that let's not separate what we want to create as public, what we want to create as private, create everything as private. Just have pointers when you are returning something. When I'm returning something over here, just return pointers to the private functionality or pointers to the private functionality that you want to be revealed as public. So that's what your revealing module pattern is going to be all about. Let me just write the implementation and then you will understand it in better way. Okay, so let's say I'm creating this variable. Okay, so now what I did, I've just created two variables. One is my name and another is my welcome message. So what I'm trying to do, that let's say right now both of these variables that I have created, they are private, but I want one of them to be accessible outside and one of them not to be accessible outside. Let's say I do not want name to be accessible outside, but I want this message to be accessible outside, which is just like a welcome message that I want to do. Now let's say if I create some function, let's say I'm just going to name it as private. Let me write it, then I'll explain it to you what exactly with it. Okay. Now, can you tell me what is the scope of all these methods and the members that I have created? What is the scope of everything that I have just written? If I say our module dot private function, if I say our module dot private function, will it work? Okay, if I say our module dot public set name, will it work? Sorry, public, yeah, public set name. Will it work now? Why not? Why won't it work? What is that scope called? Exactly, it is locally scoped, so I cannot access it outside. So now, how exactly should I access it? I have created all my variables, I have created all my methods which are no, if I say this, then that means I am setting that corresponding to the object only. But let's say this is more used when you are using your constructor pattern. It will just set the value. Still, I have to access it, right? Yeah, so if you say this, it will set the value, but I do not want to do that. I am saying that everything I need to provide, I will create everything as privately on. So what your module pattern says that whatever you need to return, you return them. You return them as objects, you return them as functions or variable as your object literal notation. So now, what your revealing module pattern say that the things that you need to return them as a reference to the variables that you are passing or as a reference to the things that you want to create. For example, let's say okay, so now what we did, everything in my module, everything in the module that I have created that is doing something, that is operating on things, is now private. What I am doing, I am creating, I am simply writing variables, or I'm just simply returning an anonymous object which is having pointers. This is a pointer. These are the pointers which are having reference to the privately owned things in my module, rather than having a combination of private and public things. Over here you see I have written a method which is public, I have written a variable which is public, and inside that obviously I'm accessing private variable, but still I'm writing public methods, I'm writing public variables. But what your revealing module pattern says, everything in your module should be private. Every variable, every data, every member of your module, every member of your object should be private. When you are returning, whenever you are returning an anonymous object, then when I simply say return, that means I'm returning an anonymous object, an object without a name. In this return statement, create reference, create pointers which will refer to the privately owned values. And this is how exactly, or this is what your revealing module pattern is all about, revealing the things which you want, but not as publicly, but just write reference to the variables that you have created. So now let's say if I provide this, what this method is going to do, this will call this object, this will call this reference, this pointer, which in turn is having a reference to a privately owned method, privately owned function, which is setting this property. And finally, if I say get name is referring to this privately owned method, which internally is calling this private function to print the name that we have just passed. So this is exactly what your revealing module pattern talks about that the things that you want to be revealed, they should be revealed by using the reference, by using a pointer which points to the private members rather than just accessing them by the usage of your private function, public methods or public members. I have not commented this. So now if you see, this is what is being printed. So simply, if you see, module pattern talks about that when you are returning an object, whenever you are writing or returning an anonymous object, within that return statement, use your object literal notation, write your public functions, write your public variables that you want to be accessible outside. Those public methods can in turn call the private methods, but your revealing module pattern says that everything in your module should be privately owned. When you are returning an anonymous object, at that time create some references that should point to those privately owned functions that are operating or that are doing the calculations within your module. So whatever you want to access them by the usage of the reference variables which are referring to the privately owned function. So now let's say if I say dot welcome, oh, I'm not printing anything in the welcome message. Yeah, it won't give me anything. Yeah, it won't give me anything. If I have to print something, I'll just have to do console.log. Okay, so this is what exactly is happening in your revealing module pattern, and this is how simple your revealing module pattern is. Do not separate what you want to access privately, what you want to access publicly. Just create everything private and then just reveal your public pointers. These are the pointers that we have towards the public, towards the private functions or private members that we have created. So just reveal the public pointers outside, and using which you can write your pattern. So this pattern comes on top of your module pattern. Because why? Simply because it's way clearer and in comparison to your module pattern. You clearly know that everything in my module is going to be private. I will just create pointers to access the things which I want to be available private, which I want to be accessed outside. So tomorrow if any changes are required, I just have to change the pointers rather than changing anything in the methods that I have provided inside. So that's what your revealing module pattern is. Okay, is this clear? All right, the next pattern that we have is called your singleton pattern. Singleton pattern is used across many languages. It's available in your Java as well. What your singleton pattern says: singleton pattern restricts the instantiation of a class to a single object. Let's say whenever I'm creating an object, anytime I'm creating an object, I'm instantiating something or some class at any given place. What your singleton pattern says, that I am going to restrict you in the manner that at any given point of time you can create only one instance of the class or any of the objects that you are creating. So right now, as JavaScript is all about creation of objects, so what your singleton pattern says, that I will allow you to return only one reference to the objects that you are creating. At any given point of time, you cannot create multiple instances of the object. You can create only one instance of the object that you want. More than one instance will not be permitted by usage of this pattern, which is your singleton pattern. What singleton pattern says, that when we are writing a singleton pattern, we will not be returning an object, we will not be returning a class or anything at all. When we are writing a singleton pattern, we return a structure in which we say that any time, any given point of time, whenever you will be creating an object, no matter how many objects you are going to create, all those times only one instance of your object will be permitted. You cannot create more than one instances of the objects at any given point of time, and that's what your singleton pattern is going to be all about: writing or creating only one instance of the objects that you are going to create. How exactly we are going to do that? Let's see. Let's say if I am going to, let me comment it, and then we will write singleton pattern. Okay, now this is in turn is obviously a module pattern only, but the way we are going to create an object, that will just be restricting anything. So in your singleton pattern, obviously we are going to follow the conventions of your module pattern and revealing module pattern, but the way what we are going to return, that's what makes it different. We will return the instance, we will return only one instance of out of it. So now let's say if I create this. uh, Let me write it, then explain you what exactly I did. I need you to explain it to me whatever you can once I'm done. Let me do something else as well. Okay, done. Okay, I'm going to unmute you guys and I want you to explain me whatever you got out of the solution that we have just provided. Nilima, whatever your understanding is, what I have just done.
We have created two objects, that is first and second, and here we have created a private function, that is initialize, and there is another public method, two public methods, because we are returning. So we are calling get instance method in the first creation of the object. Can you go down one, please?
Okay.
Yeah, we are calling get instance. From get instance, that is not equal to that variable, the private insta acne or something there, right? In the get instance function.
Okay, so what do you think will happen when I do this?
Random is equal to. Actually, as you said, we can create only one object, one instance. So it will say that like console.log first.get random number equal to second random number.
It will just generate a random number. So what do you think? What will happen if I'm doing this?
Can you go to that function get random number?
It's just math.random, randomly generating a number.
Okay, it will give the same number.
Okay, it will give the same number. Okay.
Yes.
What do you think, Mala? Mala?
Yeah.
What do you think? So I'm not expecting an absolute answer. What is your understanding out of the statements that we have written?
I think it keeps. I think it keeps it private. Just give me a second. So it's gonna keep like a private reference. That's what I understand from it. And then it's gonna give only one instance, and it's gonna shield from like the from the public.
Okay, so what I'm trying to say is, let's say if I do this singleton dot public method, that's also possible for me to do, right? That's just following my module pattern. I can still print something here, I can get the random number. Then what is the purpose of doing this?
What was it doing? Function. I have no idea.
That's okay. Okay, so this is exactly what your singleton pattern is. Singleton pattern says that if you are following me, you have to keep this in mind that you are going to access only one instance of the class, or let's say one instance of the object that you have created. So even though, so if I just do this, that means I'm following module pattern. We are following an approach. Patterns tells us that what way you should write your code. They design something for it. They allow us to create a configuration. When I'm doing this, I'm forcing my code that this singleton get instance method is returning me an object of this singleton object that I have created. It gives me one single object at any given point of time. What we are doing in this method, we are checking if this instance variable is if so basically what we are trying to do, this instance variable that we have created, if it is not being initialized, if it is not having any value, if it is blank, then initialize it, which means just call this initialize function, which is having another private method which is in private. If it is available, then just return that instance. So what we are trying to do, we are creating an object which at any given point of time should have only one instance created. When I am using this, when I am saying get instance, this get instance method will be returning you one instance of this object that we are creating, which is my singleton object, only one instance. Then if I'm saying first and second, no matter I have created two variable, but both of these variable will be referring to only one instance at any given point of time. And then when I'm saying first dot get random number and second dot get random number is just a function that generates a random number. If I would have been calling this method separately, if I say singleton dot get random number, let me show you the difference. Let me run it first. Do you see? Did I change the name of it? No. Fine. Do you see me making any mistake? If instance is equals to this, initialize. If not instance, then do this.
I think the spelling is mistake. INSTANTACNE, and then down we have.
I think I've just made that mistake anyways everywhere. Let me write it correctly. Instance.
That's the problem.
Okay, and over here instance. So that's done. Now get instance should come here, here. Alright, let's see. No, any other mistake that I've made. It's not typo. It should not be because of that though. Why is it not recognizing my return? That's right. That's right. Oh, okay. That's what I made a mistake. Now it's fine. Okay. So did you notice what mistake I made?
The curly braces?
Yeah, so I was returning two return statement at one scope only. This return, basically what we are trying to do, whatever this instance should be, so what this instance that we are creating, it should have these methods, which is my init, and which is basically everything inside my init method. So that's what exactly your return should be doing. It should return you only one instance of the object, and that instance should be containing all the methods, whether that's this private method, this random variable, the public method, which is being returned from here. So this is internally what we are doing. So everything has to come within this init function only, so that we can make sure that at any given point of time only one instance is being returned. So that's the mistake that we have been making, and that I just put a return statement outside, and that's why it was not able to read the return statement which I have put second time. But ideally what we are trying to do, instance, in this pattern we are going to return only one instance of the object at any given point of time. What that instance should do, that implementation, what type of variables it is containing, we are putting inside this method, which is my init method. What init method is containing, it is containing private function, it is containing private variable, and then it is exposing these public methods and public variables that we want to be accessible outside through the instance that we have created. So now to access anything within this, what we have to do, first of all we have to get an instance of that object. For calling this get instance function, you can obviously name it any way you want. Then using those instances, what we are doing, we are just generating we are just calling those random number function which are being exposed inside this instance. So what we did, first of all, let's say this is one section. This return statement belongs to my pattern, which is my singleton, belongs to my module, which is my singleton object over here. So what we are saying, that using my singleton, first of all get the instance. If this variable, this instance variable is not instantiated, then call this method, which is my init method within the singleton. Then what this init method is containing, this init method is containing private function, private variable, a variable which is generating a random number, and it is returning something that we want to be accessible publicly. So this init function will expose these methods, it will return this to the instance over here, and that instance further we are sharing and we are using that in our design pattern. And this is what your the singleton pattern is. If you see over here, if I say first, even though I'm getting two instances, I'm calling this function twice. Ideally it should give me two instances, but what it is giving me, it is giving me only one instance. And at any random number will every time you call a random function, it gives you a random variable. So but even though when I'm saying first dot get random number and second dot get random number, it is giving me true, both of these numbers, it is pointing to the same numbers, which means the object which is being generated, the instance which is being generated is always one. No matter how many times you call it, every time only a single instance is being generated. And if I do this, obviously I do not have access to calling the singleton dot random directly. Let's print it now. If you see over here, get random number is not a function. Why? Because I'm closing it within the init, and that init is being exposed through this get instance function, making sure that at any given point of time, not more than one instance of my class or of my object is allowed. And to get those values, to get those instances, everything I'm putting inside this function, which is again a public function that I have provided. Now, why did I write this check? This is a way for you to write a good singleton pattern every time. First of all, as we know that we are going to start only one instance, we are making sure that we are not unnecessarily creating more instances, or let's say we are not garbaging the values inside our instances. Only if my instance is not available, only then create it. If it is available, just make use of it. So this is a check which singleton pattern asks you to write for a better programming practices. At any given point of time, first check if instance is available. If it is not available, then initialize it. Else you do not have to initialize it, just return the instance. As this is what your singleton pattern is all about. Is it clear now?
Yeah.
Nilima, is it clear to you as well? Okay. See, patterns are very important because people ask questions from patterns as well. What is iffy? What is singleton pattern? Have you ever used it? So these things you should have a clear understanding about all these patterns, how exactly you can define them, how exactly you can make use of all the patterns. If someone asks you that what exactly is going to be the definition of these patterns that you can make use of. All right, so is this okay? So these were the basic patterns that have been available, or most of most used patterns that we have in JavaScript. Apart from that, there are many other patterns as well. There is something called factory pattern, there is something called observer pattern, and so on, but they are not that much in usage, and they are coming from your ESMA 5. But these were the basic patterns that we needed to talk about. We have constructor, iffy, closures, uh, we have singleton, revealing pattern, module pattern. Apart from that, there is another pattern that we discussed yesterday as well, that you can separate as well from any other pattern, that is called your prototype pattern. I'm going to ask you again, can you guys tell me what is a prototype? What is a prototype? We discussed prototypes yesterday. Okay, yes, correct. A prototype for every object is just like having a default template. Whenever you create an object, a prototype of it gets created, which is just like creation of an empty object that you have. It does not have any values. You have not put anything inside it. It's just a template that every object gets in your JavaScript as soon as you create it. So now your prototype pattern talks about valuing the prototype only. If you remember from yesterday's class, I made use of a function which was your we talked about constructor prototypes, in which we assigned values to one object to another by using the prototype of it. So whenever two objects were there, if we wanted some functions to be shared, we created them as prototypes so that everybody can share those functions and they become a part of your uh, prototypes. But that was coming the usage of having a prototype in your constructor pattern. If you have to separately make use of this pattern which talks about creation of your object by using their prototype, how exactly we can do that, or what exactly uh, how exactly you can implement this prototype pattern. Let's say if I'm creating mm, okay, let's do this. Okay. Can you tell me what this type of definition of an object is called? What is this called? Object literal, absolutely correct. This is object literal notation. So now let's say I've just created an object. Now whenever I'm going to instantiate any new object, whenever I want to instantiate object for this object literal notation, if I want to instantiate something, let me name it as car only. What I'm going to do, I will say where, let's say my car is equals to object dot create car. Now let's say console.log my car dot name. Let me refresh it first. Velocity turn. Now I want you guys to explain me now what I just did, because we discussed about prototype yesterday as well. Nilima, what happened just now? What I just did?
We have just created an object. We have created an object and just calling that object dot name and printing it.
So what is the difference? Let's say if I say simply car something like this, or if I say simply car dot name, if I do this, what is the difference between doing this and doing this?
This can be shared like this single object can be shared many times.
So what this function is doing, object dot create.
Yeah, that object dot create can be like rather than redefining it again and again, we'll just create it at an only single time.
Okay. Yeah.
That's the use of object dot create.
So correct. So what we are saying that this is, let's say this is what my object is going to be. I'm just creating a template for a car object. I'm saying the name of car should be this, and then it is having a function called drive and which should print this. Then rather than just let's say car dot name, whenever I want something similar to this car, let's say if I want a prototype, this is just like a prototype that I have created. If tomorrow I want this prototype to be available for other objects as well, what I'm saying, I'm creating another object. I'm saying object dot create car. So now the prototype of this variable, the prototype this car object would be available. Okay, so what we are saying that object dot create. So whenever we have just created this prototype and we are saying that with this prototype create other objects. If you are having similar type of functionalities available, why do you have to create objects again? You do not say where my car and then provide implementation inside that. You have a prototype available, just make use of that prototype to create new object, and this pattern is called your prototype pattern. If you remember, you can simply say when you create an object, you can simply say object dot prototype as well. By default, every object belongs to this constructor, which is your object, and that by default has a prototype, which is just an empty thing that you create. So over here, if you say object dot prototype, you are assigning a default value. But now if you want to refer to the prototype that you have created for any object, every object gets a prototype. So if you want to refer to that, this is what you are going to do. This pass that reference by in your object dot create your object by using a prototype of any other object, and this pattern is called your prototype pattern. And this is uh, what exactly you can do using your prototype pattern. As simple as that, whatever you are creating, create that as a prototype. If you have some other object available, just create that as a prototype, and this is how simply you can create your prototype pattern. Okay, clear? So prototype pattern is one of the very simplest pattern that we have available. Okay. One second. Why is it not printing? So let me come back again, let's check. Okay, so now it's printing. When I'm saying print, it's just printing the entire function that I have. Okay, let me do this. Okay, so it's not taking the prototype inside because I'm not creating it right now. Parent dot prototype dot print is equals to let me see if this works. Okay, it's printing now, but then okay, no, I'm still in the class. Okay, so we are writing the print function, then print is calling. Do you guys see any mistake that I might have made? Then we are calling this method, which is my inherit from, to create the relationship. This is my child, which is setting the name to child, and then I'm adding another property. Console.log this dot name. Aha. Silly mistakes that we make. Okay, now parent is being printed. Alright, should even work there as well. 1 second. Just give me a second, guys. Let me see why it is not working. First, here. Very strange, it's not taking the prototype. Okay, because I have not created it by object.print, object.prototype. Yeah. Okay. So I have it here. Let me just keep it outside only because I want it to be created as a prototype. All right. Still parent is coming. Then I'm saying inherit child, which is this object, and then I have parent, which is this object. We are creating a prototype from of child using parent dot prototype. Then this is the function which I have. Okay. Again, silly mistakes. C is equals to new child. C dot print. Now let's see. Okay, now first it is giving me undefined. Now at least something is coming. Print dot call dot this. Let's not do this first. Okay, now it's fine. Alright, so if you see, these were just some silly mistakes that I was making. First of all, I was just passing this object itself over here, so that's why it was giving me the complete function. Then again, let me explain it to you. What we did, we have created two objects. One is parent, one is child. We are creating another function which we are saying that this child prototype should be created from the parent. Then whenever we are creating an object of child, now if I try to access something which belongs to my parent, it still have access to that and it will print the value that I want to be printed. So then at that time, if you see, it has overridden, it has provided its own name, and then if required it can access the function which belongs to my parent as well. And this is exactly what inheritance is all about, getting or gaining the properties of the parent by usage of these types of calculation by doing something called prototype chaining. We are chaining the prototypes. First of all, there is parent, then we are chaining it to the child. If we require, you can create another child which should be a child of this child itself. Then there is going to be a template which is being created from the prototype. So this type of concept is called inheritance, and it is achieved by creating these types of variables where you provide a relationship between the parents and the child that you create by following something called your prototype chaining. Every time you create a child, you create it from the prototype of the parent, and then you doing this, you do have an access to all the properties of the parent that you have created. Any method that you have provided, again, you, if you want, you can just provide it as a normal method, but I wanted it to be provided as a prototype. And if you are providing it as a prototype, you obviously have to create those functions as well as create those instances as well as a prototype. So that is why if I keep this inside, this will not work directly. So I have to provide it outside only if I'm creating it as a prototype. If you want to create it as a normal one, that you should create inside only. So again, inheritance talks about having a relationship between a parent and a child, having objects which are related to each other, in which one is a parent and another is a child. Child receives all the properties and all the behaviors from the parent by default. So how do we achieve it? We have two functions, we have two objects, one is parent, one is child. Then we have create another function that will define the relationship between the child and parent. We are saying inside that the object that you want to create, state of child created by the prototype of the parent, so that it can have reference to everything coming from the parent. And then finally, first of all, we will call that function which describes the relationship between these two, and then finally from the child we do have an access to the things which are coming from the parent. And this concept is called your inheritance in your JavaScript. Having a relationship between parent and child, as simple as that. Having a relationship between two classes in terms of they are sharing, the child is sharing everything from the parent and then can access it if we are creating that child by the prototype of the parent. Now if you see, by default every object gets a prototype. Then the child that we are creating from the parent's prototype. If I again go and do something, if I again want to create a subchild of this child, I can again do that by creating that child from the prototype of child. So if you see, your grandchild is linked with this child, which is again linked with parent. There is a chaining of the prototype which is happening, and that is called your prototype chaining, which comes from your inheritance only. We have multiple objects and they are interlinked with each other in the manner that the prototype that you are creating, it is being created by reference of the other object. That is called your prototype chaining, which is being done in your inheritance, which is being done to achieve inheritance in your JavaScript. And this is what your inheritance is. Is this clear? Okay, where is it used in the real time? Just like whenever you have, let's say I have just given you an example of where you want to create multiple objects but you want to share something. For example, let's say just like car, if you see, if I wanted to create it, let's say tomorrow I'm creating, let's say I want to create a template. I have created an object for Hyundai make, let's say 2014. Then if I want to bring in something from 2015, a car from Hyundai 2015, I will use 2014 as prototype and I will add on the features into 2015. So that similar things I can access from 2014 as well. So whenever you have these types of configuration that you want to create, for example, let's say on your pages, if you are creating your header and footer, you are doing some JavaScripting, you have your central section is accessing some features from header, and again you are doing some sort of JavaScripting as well. Header needs to be accessed throughout multiple pages that you are creating, and you want to add on to those headers as well. Let's say if you are not logged in, for example, if you are not logged in, you simply want to provide